Thank you. My name is Hiroki Sakaji, University of Tokyo, from Japan. Today, I will talk about the economic causal chain search using a text mining technology. And I'm very thank you for giving me a chance to talk my research in this workshop. Thank you, organizers. We think causality has a central role in economic analysis. So by building a causal chain network, we will be able to infer economic impacts of various events. This figure shows the example of causal chain about Brexit. And we can find the impact of economic impact of Brexit using causal chains. This is our economic causal chain search system. So click the search button to the right of the text box to display the causal chain from the input text. By default, causal chain search system output the three causal relationships in descending order of similarities. So today, I will introduce how to construct our economic causal chain system. Our method consists of 3 steps. Step 1, our method identifies sentences that include cause-effect informations in using machine learning method. Step 2, our method obtains cause-effect expressions using syntactic patterns. In step 3, our method constructs causal chains based on phrase similarities. First, I will talk about the step 1. If there are 3 sentences, first, we found cool expressions such as due to, because, since, as, from, etc. So by using dictionaries. Then our method identifies the sentences include causality or not using the SVM with input features. Why does the model classify the sentences? I explained our method extract causal knowledge using clue expressions. However, clue expressions sometimes have another meaning. For example, the sentence has causal knowledge since it rained, the event was cancelled. However, so this sentence has no causal knowledge. I have known her since I was 4. So these 2 sentences have the clue expression since, but the later one has no causal knowledge. So we have to classify meanings of clue expressions. So we developed classification method. This method uses a support vector machine. We use the following as SVM features. We use syntactic features, semantic features, and other features. We use pairs of particles as syntactic features. We use extended language ontology based on YAGO as semantic features. And we use part of speech of morphemes just before clue expressions, and clue expressions, and morpheme unigrams and bigrams as other features. So we have to explain about the Japanese dependency parser because our method extract features using a Japanese dependency parser. Additionally, our method that extracts cause effect expressions uses Japanese dependency parser also. For example, if Japanese dependency parser analyzes a sentence, subprime loan 危機により世界不況が起こった。It means a world economy recession was caused by the subprime loan crashes. Then we can get this result. And first, the sentence is divided into bunsets. Bunsets is a basic block in Japanese composed of several words. Then it's judged which bunsets depends on which bunsets. Then, moreover, we explain about our definition. First, core phrase. Core phrase is a phrase that is your most phrase composing a clue expressions. Second, base point phrase. Base point phrase is a phrase modified by the core phrase. For example, in this sentence, 影響で in English, due to is a core phrase, and natta in English was is a base point phrase. Using Japanese dependency parser and our definitions, we explain about the pairs of particles. First, our method extracts before particles. Before particles are extracted from phrases modify the core phrase. Second, our method extracts after particles. After particles are extracted from phrases modifying a base point phrase. Finally, our method extracts the combination of before particles and after particles as a pairs of particles. In this slide, we explain about the extended language ontology. Extended language ontology is created from Japanese lexical thesaurus and Wikipedia. First, our method extracts typhoon and bridge that include the phrases modifying the core phrase or the base point phrase. Then, our method extracts the meteorological phenomenon and the traffic route as a feature from extended language ontologies like this. So we can imagine if the event concerning a meteorological phenomenon occurs, there is something impact on bridge and the traffic route. So, but now I replaced SVM to BART. So I explained the method, the old method. So now I use BART. And then in step 2, we use dependency parser and pattern matching for extracting cause expressions and effect expressions. In this slide, blue expressions are cause expressions, red expressions are effect expressions. So our extraction model is we employed our old method, Sakaji 28. So our method extracts cause effect expressions using 5 syntactic patterns. This method targets Japanese news article, but we confirmed it could extract cause effect expressions from Japanese financial statement summaries. We show one of the 5 syntactic patterns. I show the example of pattern A. In this case, or hiking in English, with is a clue expressions and a core phrase. Then nobita in English, increased is a base point phrase. Our method extracts the cause effect expressions by tracking back to the core phrase. And our method extracts the effect expressions by tracking back to the base point phrase. As a result, our method extracts the cause expression, the expansion of capital investment by semiconductor manufacturers, and the effect expression, sales of control systems for semiconductor manufacturing equipment increased. Then we gathered the cause effect pairs using our extract model. I extracted about 1 million cause effect pairs from Japanese annual reports. Finally, in step 3, we construct causal chain. First, users input the text. Then, cosine similarity between embedded representation of phrases and so we calculate the cosine similarity between embedded representations of phrases. In step 2, potential causalities with same topics are selected. In step 3, causality with similar cause expressions are added to the chain. Then step 4, repeat step 2, 3 for each effect expressions of new node. Our method can extract forward search and backward search. In forward search, we can connect the first layer's effect to second layer's cause, and second layer's effect is connected to the third layer's cause, and this. In backward search, like this. So this is our web page, and please click the tool button, and then you can get this view, and please click the causal chain search. Then first, users enter start text. The users can select the search direction from the cause to result or from result to cause. It is also possible to limit the search period of textual data. Click the search button to the right of the text box to display the causality chain from the input text. By default, 3 causal relationships are displayed in descending order of similarity, like this. And then each causality box has information of ticker code, publishing data, and the similarity. By click a box, the original sentence of financial summaries is displayed. If a user determines certain causality is not appropriate, they can delete the node by pressing the delete button. If you want to see more causal relationships, you can click the more button to increase the display of causality nodes. And if you want to further extend the causal chain from each node, click this button on the right of each node, and the related causality is added with the click node as a terminal node. This is the result of extension of the causal chain. Then you can build the above mentioned causal chain repeatedly and construct the causal chain required by users. You can save the constructed causal chain in an image file. Now I can show you an example. So, yoisho. This is our website. Then click the button And these are our constructed systems. Then click causal chain search and demonstration causal chain search. You can find this view. So, but our system targets on the only Japanese, so this is the result of our search results, and I use Google translations. So if Olympic, the first layers, we can find the Olympic cause is Olympic, and the effect is such as increased demand for IT equipment investment, introduction of the mind, and another one, the cause is the Olympic demand. The effect is the soaring material prices. And this cause effect is included in 1899 Tika code company. This is a Japanese company, Fukudagumi. This is a construction company. And so this and report published at 26 years. Then you can push the expanded button. The result is this is a second layer of the causal chain. You can find like this. Well, we can find this one. So the cause is the soaring labor cost and materials. The result is a rising construction cost. Then this cause effect expressions included in 3246 Tika code company, Causal-Chain. Its company and is real estate company in Japan. Furthermore, we expanded more causalities and this button, and we can get these results as a third layer causal chain. The cause is rising construction cost. The result is property prices for condominiums are on an upward trend. This causality is included in 6093, 6093. Escrow Agent Japan is a service company in Japan. So as a result, we got Olympic causes and condominiums price increase. I found this causal chain in 2070, and next year, some condominiums company in Japan achieved record profits. If I bought these stocks, I got many money, but I couldn't trust my system. Therefore, I lost chance. So, but you can find these causal chain constructed from several years, 2060 and 2040 and 2050. But this scenario is come true. This scenario comes true. We think causal chain can create a futuristic scenario, maybe. So this is our system. Please, please input the text and search. Please try it. Then, I introduce case study using a Causal-Chain. We calculate the impact of news about the wheat price using a Causal-Chain. This is a result of the Causal-Chain search and about the wheat price. In each layer of the Causal-Chain, we listed up related companies that appeared for the first time in that layer, like this. And this is listed up the forward search result and the backward search result. You can find so first layers. The companies in first layers deal with products made of wheat, such as flour and bread, Nishi Seikun and Nitto Fuji, flour mining, Yamazaki Pan, like this. In second layer, the layer deepens, the relationship with wheat becomes indirect. Second layer, Toso Corporation is a chemical company using so flour and wheat. In third layer, more indirect, and so Ajinomoto is a umami seasoning for processed food manufacturing, and Meiji Machine Company is a food industrial machine manufacturers. And this is the result of the backward search. And second layer, as you move back in the Causal-Chain, companies that deal with a broader range of products appear. So second layers show agricultural machinery manufacturer. In third layers, we can find Mitsui. This is a trending farm company. So we conduct a case study about international wheat price published by July 24 News. And this is about the international wheat price is high for the first time in a month with a prospect of the reduced production in France. So each lines indicate each stocks excess returns. Then we calculated the absolute excess returns for each company because we want to know impact of the Causal-Chain. Then we calculated average absolute excess return in first layers. Then we calculate first layer and second layers and the third layers average absolute excess returns. So like this. So you can find all layers average absolute excess returns increase within a few days after publishing the news. However, first and second layers move flat after a few days, like this. On the other hand, third layer move persistence. We consider that traders focus on effect, and additionally, many traders are difficult to imagine a deep impact. Therefore, we consider that the impact of third layer companies had remained. But in backward search, we cannot clear changes. This is a case study 2 about the September 6th news. Wheat international price dropped by 4%. Russia says no export restrictions. In forward search, we cannot clear changes. However, in backward search, we can find the same result as case 1. Case 1 in forward search. because we consider that traders focuses on the background. Therefore, background searches result affect excess returns. In the future work, and we consider about the sentiment analysis and pruning the causal chains. And finally, I introduced the economic indicator predictions. So this is that of the infectious disease causal chains. If this is the effect expressions supply and demand on the way to easing, and room rate has recently seen weakness. This effect related to the economic indicator such as occupancy rate. So we can find the economic indicator using a causal chain result automatically. So we use economic text provided by company deep data research. Then the data is a monthly corporate reports published on the official homepages, and the data volume is 150,000. The odds ratio is a statistical scale that shows the ease of the occurrence of an event in two groups. In this case, we compared probability of appearance of the specific text in certain indicators and probability of the appearance of the text in the whole. If odds ratio is high, the text tends to concentrate on the certain indicator. In this experiment, the frequency of the appearance of each index is used for calculation. But since the frequency is zero, the correction odds ratio was used so as not to set then this 0 to 0. This is the case 1. We can find the guest room occupancy rate like this. Then this is a case 2, U.S. presidential election, and case 3, global warming. So we can find the foreign exchange and CO2 reduction as economic indicators related to the G's case. And in this case, Olympic, left side is 2016 result. This result showed the number of stores, number of customers, unit price per customers, number of stores opened. On the other hand, in 2020 results, and we extracted the number of stores closed, occupancy rate, because in 2020, so COVID-19 affected these companies. So in conclusion, I introduced our causal chain search system and event study using a causal chain. And now we are constructing an English causal chain from 10K and 10Q reports. And thank you for your attention.
Yeah, thank you for your talk. I see your causal chain looks like a tree structure of exploration, right? But there may be many ways of expressing the same information. And I imagine it naturally forms a graph instead.
Yeah.
Have you considered any research around kind of different expressions of the same outcomes from this causal chain and graph structure instead of tree structure?
Sorry, one more again. Sorry.
Yeah, so this looks like a tree structure. Right?
Yeah, I know.
But you could maybe say property prices increase in one outcome, but you maybe have another outcome like land value increases or something instead. So property and land value are two ways of saying roughly the same thing. And so maybe if this naturally forms a graph structure instead where you map to this. Have you thought about that at all, like graph structure for causal chain instead?
Yeah. So yeah, but no, we can't. So these graph Google graph structures not yet. So I will try to later. Thank you.
You're now constructing this in an English version. Do you think there are some particular challenges involved in it, or will it be easy to apply your methods also to English language?
So there are no causal extraction method. So general causal extraction method in English. Therefore now I create a model using a GCN and BAT for extracting causal knowledge in English, but it's BAT for constructing the causal knowledge because expressions include racks, and so therefore the BAT extract the expressions as a series, so language series. Therefore, some words racks can't extract as cause or effect. Therefore, we can get enough expressions. Therefore, we now construct the extraction system using syntactic patterns. so this is old style extraction method, but good extract and long using for constructing causal chains. Therefore, please wait. So our method, we will open the methods. Thank you very much.
So I might have missed your explanation, but I understood the forward search process. But can you explain more about the backward process?
Backward process?
Yeah.
This is?
Yes, please.
So backward process is we connect the causality in the cause and secondary effect, and secondary cause and third effect connected. So なんつったらいいんだろうな。そっかそっか。So normally cause effect is a cause and effect, and another cause and effect. But backward search is find so cause of the event. So therefore, our system so backtrace the causal chains and so effect and cause and another effect and connect another effect and so secondary cause and another causality effect like this. なんつってんの？
Yep. Understood.
Okay, sorry.
Thank you.
Thank you very much.